Good morning, class. So we're still busy with Euclidean geometry. You had for homework 9.6, correct? Which was dealing with the application of the tan-core theorem. Okay? 9.6 on page 308. We are told that each of the following examples determine the value of the variables, giving reasons for your statements. O is the center of the circle, TAN is a tangent. So looking at number 1, A, firstly, number 1A. So A is equal to 90 minus 74, which is 16. Why? Radius perpendicular to tangent. Not so? We'll do that and move it here. Right, radius perpendicular to tangent. Okay. So this is 16. B, how are you going to calculate B? Tan-core theorem. So B is the same as 74. Tan-core theorem. Okay. C is double B. So it's 2 times 74, which is 148. Angle at center is equal to 2 times the angle at circumference. Okay. You guys okay with that? Right. Look at B. A is equal to 90. Why? Radius perpendicular to tangent. Okay? I will calculate B. Sum of triangles. So B is going to be 180 minus 90 minus 48, which is 42 degrees. That is a sum or interior angles of a triangle. Okay. I will calculate C. Angle at center is 2 times angle at circumference. So C is 42 over 2, which is 21 degrees. Okay. Any confusion there? No? Yes? Yeah. You could have first gone with angles, then this should have also been C. No? Is that what you say? And then exterior angles equal the sum of two interior opposites. Or angles on a straight line and then sum of triangles. Also fine. But if you go that route, you must say all that reasons. Okay. But you must remember when we set up the memo, we try and look for the easier or the quickest way to get that, and that's how we allocate marks.
Wait, sir?
Yes?
If I go back to the big movie, so you divide by this triangle, if you think about it.
Say again?
So you divide by this log the triangle, but
what's your reason going to be? Half a triangle. You must have a reason for your statement.
But is that not half a triangle? Yes, right?
No?
No.
This is not a triangle, yeah? This is not a triangle.
But
If that was a chord.
But because it has an arc, we can use
A chord. A triangle is made up of lines, not an arc.
no, because I got confused because it was if you look at the side, it's kind of more triangle, so that's why I didn't want to use angle at center.
You see that this point here, this angle at center is subtended by that arc. And that same arc is subtending an angle at circumference. Yes. Okay. You look at C. What can be calculated here at C? A. A is equal to 90 minus 27. Why? Radius perpendicular to tangent, which gives you 63 degrees. Okay. B 90. Why is B 90? Angle in semicircle. C 180 minus 90 minus 63. Or we could have just said 27. Why is C 27? Tan code here. You see how easy it is if you know all your theorems. You will be able to see the things a bit easier. Okay. Any confusion here? Look at E. For E, what can be calculated first here? Both of these are tangents. Not so? So if SPN is a tangent and TAN is tangents, then what can we say? We can say that A is equal to B. Why? No. Let's say something private. You see I was going to write now angles opposite equal sides. But was the sides marked equal? No. That's why I have to first say that PN is equal to AN. Why? Tangent from external point. Or tangent from common point. Okay? So now we can say that A is equal to B. Why? Angles opposite equal sides. So now we know that A plus B, which is also A plus 50, is equal to 180. Why? Interior angles of a triangle. And that is triangle APN. So I have 2A is equal to 180 minus 50 is 130. Divided by 2 is going to give you 65 degrees. A is 65 and B is 65. Again, note I'm populating the diagram. Okay? Now what? C is equal to what? C is equal to 65. Why? It is not a triangle here, and a tangent thing. So what is the reason here? Tan chord theorem. Okay, so there is 65. I have to calculate D. radius perpendicular to tangent. So A is equal to 90 minus 65. Which is 25 degrees. Sorry? D. D and D is definitely not the same as A. So we have A already. Okay, any confusion here? No? Look at D. As I see, these lines will be parallel, not so? You guys indicated, but it is parallel in your books. Okay. So what can be calculated first? A. A is equal to 59 degrees. Why is A 59? The tan code theorem. Okay. Can you calculate B? Yes. B is equal to 59 degrees. Why? As you can see, alternate angles. Alternate angles with Tn being parallel. Okay, now there's no, the other line is not named, so I don't need to say which lines are parallel there. 59. C, also 59. Why? Also alternate angles, or you can say tan chord theorem. The last one. D. A sum of triangles or angles on the straight line. Both is acceptable. Not so. So D plus 59 times 2 equals 180. Sum of triangles. So D is equal to 180 minus 59 is 118 is 62 degrees. Let's check if that's correct.
Yes.
Okay. Any confusion here? Any questions with regards to what we have so far? F. What can we say about F? A is equal to 76. Why? Tan chord theta. Okay. Now this is also B here. Not so? So what can we say? 2b plus 76 is equal to 180. Why? I used two theorems here. Sum of triangles, and what was the other one I used? Angles opposite equal. If I use two theorems like that, I must say both. Okay, or you could have said angles opposite equal side and then sum of triangles. Okay? It would have been better actually. So you're saying the order in which you're doing it as well. So you take 76 over, then divide by 2, B works out to be? Sorry? 52. Can I say this angle is 90 here? No? Why? It's not your diameter or radius. Your diameter is this. Now what we're going to do? I can say that P1 is also 76 degrees. Why is P1 76? What do you have to say first? You have to say that AN equal to, that's going to cost you a mark, maybe don't say this first. Why? Tangents from common point. Okay? So now P1 is 76. Why? Angles opposite, equal sides. So C is going to be 180 minus 76 minus 76. Why? Sum of triangles. And it's triangle PAN, which is then 154, which is 26. Is that correct? 28. Yeah, 28. Not I said 4, it must be 2. Okay. Then we went on to, of course, the next page. G. Right, what can we see at first? Sorry? A is 58. Why? And both here. Right? What can we say after that? B? 2 times 58, which is 116. Or you could have said B is 116, no problem. Angle at center equal to 2 times angle at, okay, 116. Next, C, 58. Why? See the Z being formed there. Alternate angles. No name on the second line, so no name needed. You don't have to say which lines are parallel. That is 58. D. Sorry? 90 minus 58. Why? Why? Radius perpendicular to tangent. That gives us 30? D 30. D is equal to 32. Okay, any issues there? No? Last one from number 1. H. What can we say here? A is equal to 70 degrees. Why? Tan code theorem. Okay. What else? B is equal to 180 minus 70. Why? Opposite angles of a cyclic quad, which is 110. C? This is also C. No marking here, so I can't name the angle. Okay? So I'm going to calculate C. C plus 70 equals 180. So what do I write as a reason here? Angles opposite equal sides as well as interior angles of a triangle. Not so. So that's going to give us, C is going to be 180 minus 70 is 110 divided by 2 is 55 degrees. Can I say that this is going to be 90 here? Why not? They didn't tell us it's a diameter. So we're going to calculate D. Angles on a straight line? Yes. Or tan chord theorem. That's actually equal to. Okay? Either one. You get to the mark. So D is equal to 55 degrees tan chord theorem. Okay? Any issues there? No? Number 3. In number 3 we are told, given that TAN is a tangent to the circle. People, if this is a tangent, what do we know? If this is a tangent, what do we know? Angle A1 is equal to C1, which is 30. Why? Tan chord theorem. Then we are told that we also know that this angle here is also equal to that angle, but we don't mention it. We just say the minimum, so that it can give us an idea of what's happening. Okay. Then we know that TN is parallel to CD. TN is parallel to CD. So what can be determined? What can be concluded from that? That angle T is equal to C2. Why? Alternate angles. Can you see that? Then we are told that CE is produced to meet the tangent at T. C1 is 30, E is 51. Calculate the size of angle A1. But A1 we know already, not so. What's angle A1 equal to? 30 degrees. Why? Tan chord theorem. Tan and the chord, no? Is 30 degrees. B. They want you to work out angle T. How do you work out angle T? Sorry? Okay, calculate A2. Yes, sum of triangles. And then sum of triangles again. Not so? But it's the easier one. Exterior angle of a triangle. Did you see this here? You guys see that? Let's go with that. So angle T plus 30 degrees equals 51. It's an exterior angle of triangle equal to sum of the interior opposite. It's the exterior angle of triangle AET. So angle T is equal to 51 minus 30, which is 21 degrees. Okay. Question C, they ask you to work out C2. C2 is going to be what? 21 degrees. Why? alternate angles are equal. Alternate angles with CD being parallel to NT. D. I'm going to calculate angle D. Cyclic what? So D is coupled with B2. I mean A2. So I must calculate A2 first. Not so. So A2 is equal to 180 minus 30 minus 51, which is 99. Why? Interior angles of a triangle. And it's triangle CAE. The 99 here. Okay? So angle D is equal to 180 minus 99, which is 71. 81. Why? Opposite angles of a cyclic chord. And there we go. Okay? Any confusion here? Number 5. Two circles touch at A. SAR is a common tangent. Common tangent means to say it's a tangent to both circles. So if that's a tangent, what do we know? We know that A1 is equal to E2. Why? Tan cot. A1 is also equal to C. Why? Tan cot. So what do you see? These lines are equal now. So that means to say that BC is actually parallel to PE. Why? DE. Corresponding angles are equal. Okay, so we can actually prove that those lines are parallel. Let's carry on. Then we are told that, well, there they ask you to prove exactly what we showed you. Alright, so if you like, you can bring in your x to that. If you don't like, you work without your x. Okay. For those of you who don't have x's, don't have to work with x. Okay. So let's go. So we say let A1 equal x. Okay. If you're not going to work with the x, you say A1 is equal to E2. Reason? A1 is equal to C. Reason? Therefore E2 is equal to C. Okay? That's without the x. However, E2 is equal to xy. Tan cot theorem. A1 is also equal to C. So angle C is also equal to x. Tan cot theorem. So what can we say? So we state the obvious first. We say since E2 is equal to angle C, which is equal to x. Therefore, BC is parallel to DE. Why? Because corresponding angles are equal. Here you must say the angles are equal. 4 marks on something like this. Okay. Any questions here? Question 7.